All right, so on those, what was the function? I don't have it in front of me. What was the top?
2x squared plus x minus 1.
Plus x minus 1. And the bottom?
X squared plus x minus 2.
All right. And we want to talk about what are the horizontal and vertical asymptotes, right? That's what the question was. So this is on the bottom of 2.6. So let's talk about how we can find those. So first, let's think of our horizontal asymptotes. How can we find our horizontal asymptotes? Your horizontal asymptotes, you want to look at x going to infinity and x going to negative infinity. So we want to look at these two limits. So we did this last week, 2.6. We want to look at, okay, what is the limit of f of x as x goes to infinity? Remember how we did that? What can we do? We can basically say, this basically becomes like what? 2x squared over x squared, right? Because all of the plus minus ones and plus twos and all that kind of stuff doesn't really matter when x gets really, really big, right? Now, so we can simplify it down to here. These we also call these the end behavior terms, whatever terminology you want to use. And now you can say, well, now we can cancel out the x squareds. And that's just 2. If we look at to negative infinity, is that going to be any different? No, that's going to be the same thing. That's 2. Understand, we do not want to say this. We do not want to plug infinity in and say we get 2 times infinity time over infinity and then cancel our infinities. That is not true. You can't cancel infinities. They're not numbers. But you can cancel x's because that's using our algebra. Okay? So that is our vertical asymptotes. So horizontal asymptotes. How do we do vertical asymptotes? So if we want to find our vertical asymptotes, we take our function and how do we find vertical asymptotes? Where do we look? Where the bottom is 0. So let's factor the bottom. So we factor the bottom, we get x plus 2, and we get x minus 1. Well, let's see both of those and see what happens. So we know, one of the reasons we kind of skipped this is this was before, we kind of did the other part before we got to the continuity. Now that we have kind of continuity, we can talk about this. We know this function is undefined at -2 and 1, right? But we don't know, are both of those vertical asymptotes? Or maybe one of those is a removable discontinuity. It's not an asymptote. So what we want to do is we want to plug 1 and -2 back in. So if we plug 1 in, the bottom goes to 0 on both of these. But what happens to the top? So if I put 1 in the top, I get 2 plus 1 minus 1, which would be 2. And if I put -2 in there, what do I get? Do I get 0, I guess is the question. No, I don't. I get, that's 8, and -3 is 5. So both of those have a number over 0, which tells me in terms of discontinuity, both of those are infinite discontinuities, right? Both of those are going to be vertical asymptotes. Remember, if we got 0 over 0, that means you have to do more work, okay? Now, once we know that, though, we can think about this a little bit. What happens if we look at the limit as x approaches 1 from the right and the left? So let's see what happens as we approach 1 from the right and the left. Well, we know the bottom of both of these go to 0. Now, let me change something to make sure we understand this. As you plug 1 in here, x plus 2 becomes 3. So this is kind of like 3 times 0 on the bottom. And so is that 0? As I approach 1 from the right, does x plus 1, x minus 1, is that a positive or a negative 0 if I approach from the right? Positive 0. This is a negative 0. So we know here we have a positive 0. Here we have a negative 0. And both of these, if you plug it into the top, we kind of already did it over there, you get 2. So what does that tell us about you approach 1 from the right, you get infinity, and from the left, you get negative infinity. Okay. Now, let's have you try these two. Find those two limits. See if you can find those two limits yourself. All right, so we get both of these are going to, if I plug negative 2 in here, I get 0. And I got to consider, if I put negative 2 in here, what do I get? Negative 3, right? So now, when I consider my 0, as I approach negative 2 from the right, this is going to be a positive or negative 0. Positive, but a positive times a negative, this actually gives me a negative. And then this is going to be a negative 0, but negative and a negative gives me a negative. I get 5 on the top. We've already done that. So this is going to be negative infinity. Which one? Oh, this should be a positive. I'm sorry. That should be a positive. Okay. So let's look at, let's actually look at the graph. 2x squared, was it just x minus 1, was it? Do I have that right? Is that what the numerator is?
Yeah. No, it's minus 1.
Here.
Yeah.
So as you approach negative 1, as you approach 1, from the right it went to positive, the left it went to negative. At negative 2, from the left it went to positive, from the right it went to negative. Okay. So, and as we look at all that, you may think, well, that's a lot of work I can do. I could have graphed it and got the same kind of stuff easily from graphing it, which is true. One of the things we work at this year is trying to do stuff where we don't just look at the graph, because one, will eventually do stuff like this where you have variables, and then two, for those of you that are going to go on to Calc 2 and beyond, you'll do this stuff in higher dimensions, multivariate calculus, and then you can't do this stuff, you can't graph it, so you have to understand more the algebra. Okay. All right, so let's do another one of these. So if you have space, or if you want to grab another piece of paper, a piece of scrap paper or whatever, if you have paper, let's do the same thing. Find the vertical and horizontal asymptotes of that function. So find the vertical and horizontal asymptotes. Okay, 1 second. Up. So, factor the bottom. So we have -3 and 2 are our vertical asymptotes. We plug those in. If I put 3 in the -3 in the top, I get 9. And then -6 minus 8,
That's not 7.
which would be -6 is, what's that?
Never mind.
All right, wouldn't that be -3 squared plus 2 times -3 minus 8, which would be 9 minus 6 minus 8.
I kept 3 positive.
Get -5 over 0. And then here, if we plug 2 in, we get 2 squared plus 2 times 2 minus 8, which gives us 0 over 0. So what does that mean?
Gotta do more.
Gotta do more. And what more work would you do? Factor the top. And the top factors into x plus 4, x minus 2. Which then, this can cancel. So that tells us, what do we have at 2? So if we think of discontinuity, this is infinite discontinuity because we got a number over 0. That's going to be a vertical asymptote. What happens when we get 0 over 0 and then we can remove those factors? That's removable discontinuity. So where is our vertical asymptote at?
6 over 5.
Is at -3.
The other one just doesn't.
You just don't do anything?
This one?
Yeah.
Right. Because it's removable, it's not a vertical asymptote. It's discontinuous, but it's not a vertical asymptote. Okay. So we then could look at what happens to -3 from the right and the left to try to figure out positive or negative on either side. So let me let's just graph it to kind of understand here what we have. I gotta go back here. And this was x squared plus 2x minus 8
Yeah.
and x squared plus x minus 6. Is that right?
Yep.
So you can see at -3, we have a vertical. Now at 2, we can't see it here. If I do zoom 4, you can see now what do we have at 2? We have a hole because this is a removable discontinuity. Okay. And I didn't write it up here, we mentioned it, but let me go back to here. If we wanted to find our horizontal asymptotes, we would take the limit as x goes to infinity and negative infinity, and like you said, those are equal to 1, right? Because you just end up with x squared over x squared, which is just 1. Okay? All right. This is going to lead us into our first project. And I'll talk a little bit about it here, and then we're going to spend more time tomorrow kind of preparing for this. So, this project you will examine the limits as they apply to curve sketching. All mathematics is to be shown. You are to determine the function that will have the following characteristics. A vertical asymptote at A, and I will tell you what that is in a second, and a following limits. The limit as x goes to infinity of f of x is b, and the limit as x goes to negative infinity is b. So that each function will require what a and b are. Okay, so step 1, give the formula for your function and explain how you determined it. 2, determine the limits as x approaches a, both from the left and the right side, showing the math and explaining in words how you determine those limits. Everything you need to explain the words we've already said. So this is going to basically be kind of writing this out in words. 3, show the limit as x approaches plus or minus infinity is b. Explain in words how you determine those limits without using a calculator or graphs. What I mean by that is you can use a calculator and graphs to help you, but your explanation should not be about looking at the graph or looking at a calculator or something like that, right? It should be explaining it more in words. And then 4, graph a function on Desmos 3 times, and it explains the windows. So tomorrow what we're going to do is, this says copy those graphs onto the paper. We're going to just do this on a Google Docs and then hand it in, so you just cut and paste those graphs onto your Google Docs when you turn it in, okay? And then finally, the last question is, what do you notice as you go through that, okay? As you do this, all explanations should be in the correct notation and in complete sentences. I'll explain more about this tomorrow, but I want this entire thing typed. So what we are going to spend time tomorrow doing is looking at if you are doing this kind of stuff, how do you type all that into a Word document or a Google Docs? That's what we're going to work on tomorrow, is how do you type, all of this stuff in, how you can do that, okay? So one of the goals this year as we do projects that have you type stuff is to get you to type math. And how do we do that? Not super hard. I think it'll be easy for you to kind of understand. But that's what we want to do, is to learn how to actually type math in your document, okay? All right, now, what I want to do here, though, finish up today.
Will this be due Monday?
No, I'm not sure when it's due. I'll give you a week or something.
Okay.
It's not that bad, honestly. It's a pretty, all right, we're going to pick out what your A and B are, okay? So, first, 5 is your A, your B is 2. Second, 9 is your A, 8 is your B. So that doesn't really change the problem at all, to be honest. Okay. So those are your 2 numbers. You can write them down on your paper. And then tomorrow we'll talk about typing this and how you do that. At this point, you got a few minutes left. You probably can start thinking about, like, number 1, what's your function? And I should say this is designed to be like an individual project, not like a group project that you help. If you have a question, please come talk to me, but it's not necessarily designed that you work together.